All right, so this is probably going to be the last exercise we'll be considering on circuit geometry for now. So there are actually a lot of questions on circuit geometry that require different types of theorems. Um, but we've considered just some few theorems and the exercises that involve those theorems. Well, maybe in the future we'll be adding more theorems and more exercises relating to all those other theorems. But for now, this is a question that says find the value of um, angle DCB. So angle DCB, let us look for that. So this is D, and this is C, and this is B. So we can say angle DCB is is this part here. So that is angle DCB, and it seems like angle DCB involves like three angles here. One angle here, another angle here, another angle here. So basically, for us to be able to find this, we need a theorem. And the way this question appears, you notice that it appears in the form of segments where um, two lines drawn from a particular point to another point is also drawn to another point in another part of the circle, forming different segments. So actually, one theorem that involves segments is angles in the same segments are equal. And if you notice, we used to have, let's say, if we have a circle like this, and then you draw maybe an angle subtended at this point, like this, and also like this. Then also from this same segment where you draw these two lines to, sorry, you actually can get another subtended angle. Let's say from this segment, from this point here, to another point maybe here in the circumference of the circle. And then from here also you draw to that same point, so that it subtends at this point from these 2 points. Let me draw this well. Okay, so that it subtends like this. So we get two subtended angles from the same segment, one going to this point and this point, and one from this same point going to another point and coming back to this point. Okay, so the theorem says that once you have something like this, two subtended angles or more subtended angles coming from the same segment, they form equal angles. That is the point. So we are going to look for that in this question here. Let's see if we can find subtended angles like that, and then we'll get the same segment to find angle DCB. Okay, so let's start with this first one here. Let's see. Let's notice angle 52 here. You see where angle 52 is formed from these 2 points here. Let's see. Angle 52 is formed from the first point being here up to this point here, and then it's also formed from these other points. So you see this is angle 52. So these are the 2 points angle 52 is subtended from, like, yeah. So let me just indicate that for you. And then you see that from these same 2 points you can get another angle, subtended angle. So you see from this same point, you see another angle is formed along this line. There's another subtended angle here, and you see it comes down to this. Why is my pen doing that? It goes to this point and comes down along to this other, to the same point that the 52 degrees is formed from. So basically, 52 degrees and this other subtended angle are on the same segment. So that means we can say this angle here is 52 degrees. Okay. Now let's see if we can get another one. Let's see the one for 45. The one for 45, you notice that the angle subtended that give was 45 degrees. You notice this is 45 degrees here. Okay, let me not use yellow. I've used yellow before. Okay, so let's see this. Okay, so this is angle 45 degrees. So it's subtended from these 2 points. One here, this point here, and also another point here, this point here. So from this point and this point, you get angle 45 degrees. Now, do we still have another subtended angle from these 2 points? This one and this point EA. So if you notice from this A point, you see that the line is drawn down to this point here, and then it goes down again to that other point. That's 45 degrees subtended. So you see that it comes from the same segment that gives you 45 degrees. So this angle here, since it's in the same segment with 45 degrees, is 45 degrees because angles in the same segment are equal. You see that? Now, what about 10 degrees? Now let's see the points that form 10 degrees, where 10 degrees subtended from 2 points actually. We'll see, let's see what color will I use. Let's see, green. Okay, so if you see 10 degrees, from this point, we have one line going down up to 10 degrees here, and also coming down to this point A. So 10 degrees from the 2 points B and A. So that's a subtended angle that gives you 10 degrees. But is there any other angle formed from these same 2 points here? So we see one coming down this way. Oh shit. Oh, sorry. Okay, see one coming down this way. I cannot achieve a straight line. One coming down this way, and also going back again to the same point. So you see it's subtended at this point to give us this angle here. So this angle, since it is in the same segment with 10 degrees, we call this angle 10 degrees. So we've gotten all the angles in angle DCB. If you notice, angle DCB, which we said earlier, is this angle here to this angle here. So everything here is angle DCB, and we just found out that the sum of 52 degrees, 45 degrees, and 10 degrees, angle DCB, is equal to 52 degrees plus 45 degrees plus 10 degrees. So that will give us what? This is actually 55 degrees plus that's 117 degrees, I suppose. 55 degrees plus 7, yeah, 107 degrees, sorry. 107 degrees. Let me write that. Well, my calculation was wrong there. 107 degrees. I just hope that's correct. 107 degrees. So let's do 10 plus 45 is 55. 55 plus this is 107 degrees. So that is our answer for angle DCB. And if you notice how we got it is for us to just understand the theorems. And well, how did we know that it was the theorem about segments, such subtended angles or angle in the same segment are equal? Well, if you look at it, it's most times very obvious. Since the theorem actually involves angles subtended at the circumference most times like that. This one it's really obvious because the only way most times you can get that is looking at the angles in the same segments are equal, especially what they asked us to find, angle DCB. It was just very obvious, like it has to be that theorem. So if you study all the theorems, I think once you know them very well to an extent, you easily see where to apply them. Yeah. So this is actually the last video on circuit geometry. In the future, we'll add more exercises and more theorems. Well, if you do not understand any of the exercises we've done, or you do not still understand circuit geometry, you can ask questions. And if you want a direct discussion, you can check. Just text me on JD Mass on Facebook. I will drop a link below so that you can do that, or send me a message on Instagram. Possibly, I'll send a link. I'll put a link down there so that you can also do that. Okay. So thank you very much for watching. See you in another video.